That's what it is, to hide the differences between subtypes from your users of your code. Got it. Got it. Okay, so methods on different classes can have the same signature. They can, but they shouldn't. They can, though. Def add return this, def add ABC, return ABC have the same signature. I'm not sure. I'm not sure. So what is a function signature? Let's see. This would work, by the way. You just have, just a AB kind of two methods. One would just be overridden when you have three parameters. But okay, so let's see. So a function signature or method signature includes the name, inputs, and outputs of a function or method. For example, the hit by fire in the human and archer classes have identical signatures. Hit by fire, hit by fire. Both methods have the same name, take 0 inputs, and return integers. If any of those things were different, they would have different function signatures. Okay, so these have different function signatures. Sweet, cool. So it's a good idea to use blank when overriding a parent's method from a child class. Let's see. So it's a good idea. It's a good idea to overwrite same function signature, different function signatures. It's a good idea to use different function signatures when overriding a parent's method from a child class. I would think so. I would think so. I was wrong. I was wrong again. Okay, so it's a good idea to use the same function signature when overriding parent's method from a child class. Now, I'm not understanding that fully. So if here we have the same function signature. Oh, you know what? That does make sense. Okay, so if we have a class human hit by fire and archer hit by fire, but we're changing the value here, it's still the same function signature here, right? We're not passing in more parameters. That makes sense. That makes sense because you would still want to use the same logic from this human class. Okay, so let's get cooking. We ran through a few here. We got a little skillet or a little grease in the skillet here. Okay, so operator overloading. Another kind of built-in polymorphism in Python is the ability to override how an operator works. For example, the plus operator works for built-in types like integers and strings. Custom classes, difference here, we're adding integers. Difference here, we're just adding strings right next to each other. So custom classes, on the other hand, don't really have any built-in support for those operators, so we actually have to make them. Interesting. So this would be an error because there's not an addition here. Okay. So however, we can add our own support. So create an add self other method in Python. We'll use it. Okay, so that's kind of cool that Python knows that this means add, but it looks like we have to kind of build a function to make this work. So I don't know if so this is specific to being a constructor. So is this denoted specifically for the add class? Is there also subtract one and division one? So that's probably a set of these that would be informative to understand. So now when we add P1 plus P2 is executed under the hood, Python interpreter just calls P1 add P2. Cool. Fancy dancy. Fancy dancy. So in the assignment, in the Age of Dragons, players can upgrade their weaponry to make crafting simple for other developers. We'll use operating overloading on the sword class. The plus operator should craft the swords. Note how the test suite uses the plus operator in the swords. So let's see. Where is it? Let's see some pluses here. I don't see very many plus operators, right? Oh, right here. Boom. Result sword 1 plus sword 2. Cool. Okay, so create and add self and other function method on the sword class. It will be used to craft two swords together to create a new sword. So sword type is just a string of one of these. So if two bronze swords are together, return a new iron sword. Okay, so let's see this real quick. So self.point y return point xy. So I'm a little, oh, I see. So self.x, self.y, point.x, point.y. Okay, so self.if self.sword type equals bronze, and right, and it said do the same for this one for the other sword type, right? We need to do something, which is return iron. And it looks like this bit of logic is something we could probably start to use for our basis here. So if two iron swords are crafted together, we can return steel. If a player tries to craft anything other than two bronze swords or two iron swords, just raise an exception, says cannot craft. Cool. So we could also just throw this right here, I believe. Raise exception, cannot craft. Let's try. We passed a few, failed some. So let's see what's going on. So we have if self that this. So do we need to return sword XY? Oh, we do. We definitely do. That would make sense. So sword, XY, boom, like this, I believe. Boom. Let's try. All right. We're building some swords, folks. We're building some swords. So which type of inverse of multiply? So multiply, what's the inverse of multiply? I would imagine divide. True division? Let's try. Let's try. There it is. There it is. So these are the things that I want to ask about for these kind of built-in Python compiler methods. But awesome. So overloading built-in methods. Last but not least, let's take a look at some of the built-in methods we can overload in Python. While there isn't a default behavior for arithmetic operators like we just saw, there's a default behavior for printing a class. So let's see, we're printing P1 prints the object. That's not super useful. Let's teach Let's teach instances of our point objects to print themselves. The string method, short for string, lets us do just that. It takes no inputs, but returns a string that will be printed to the console when someone passes in a class or one of these objects within Python. So let's see how they use it. So print P1 returns an F string right here. So let's see. So we could then print the point, but it seems like there's an opportunity here to build this within a class within the Python interpreter. So you could just print an object, but maybe you wouldn't actually want to do that. That actually makes sense. Maybe you wouldn't want to default to printing strings. Okay, so we've done this. We have this. Let's see. So we could print the self.name and self.color. Let's see what else they want us to add here. So when building a dragon, dragons are egotistical creatures. Understandable. They're big beasts who could breathe fire. Completely understandable. You know, I might have a little ego on my shoulder if I could do the same, or even not, you know. So let's give them a great form. Let's not judge dragons. You know what I mean? Let's. It's an inclusive environment we're building. Okay, so let's give them a great format for announcing their presence in Age of Dragons. When print is called on an instance of dragons, I want the string of this. Okay, so let's see. So I am 0, the blue dragon or something, right? Seems to be appropriate, and I think that's all we needed. That's all we needed. So this is great. So now if we use this, right, so we could say dragon, and maybe his name is Max, and he's the gold dragon, right? Now we could print dragon, right? And we should be able to see it. Let's maybe run this. So here is Max, right? Where is it? I am Max, the gold dragon. Sweet. Crushed it. Max is such an inviting dragon name, you know what I mean? It's like, oh, I'm Starboard, the dragon of night. I'm Dragon Ocelot, the pink dragon, right? And then it's like, hey, I'm Max. You know, like just a friendly dragon who lights fires for you. You know, what do you need? You need your soup warmed. You need a village burnt down. I'm your friendly dragon. You know, I can make it happen for you. Okay, so we have our 2 challenges. We'll wrap it up here. This is great. So, and I think this is actually the last bit of object-oriented programming. So the card class, the same friend who contacted you about creating a card program to shuffle cards, has asked you to create a little bit more about his program. He wants you to build a card type that's a little bit more robust so that different games can be created. You've been asked to add functionality to make comparisons between the suits and the ranks of different cards. Challenge. Complete the card class. You need to define a constructor that takes in the rank and suit. So let's see. So we need self.rank equals rank. And we have the self.suit equals the suit as parameters, and sets rank, suit, and rank index and suit index to instance variables. Now that I'm not understanding. So define a constructor that takes rank and suit as 2 parameters, rank, suit, and rank index, suit index. What would the rank and suit index be? Hey. Okay, so maybe is this what they are requiring? Something like that. You will need the indexes of the ranks and suits to help you compare them against each other. Keep in mind that a rank and a suit are just strings within a list. Right. They are just strings within a list. Okay, so we're passed in these lists, but we need the index of them as well. So do I need to instantiate that of passing these bad boys in? Boom, rank index, suit index, right? I don't know if this will mess up the whole testing suite. Let's see what they got here. Run cases. Let's see. So they do have rank, suit, rank, suit. No, they're just passing in just the rank and suit in the card. Okay, so we're not going to do that. That won't fly. Okay, so you will need the indexes. Boom. Overload the comparisons operators with this. Overload the comparison operators with this. Boom. Greater than, equal, less than. ranking the cards. A card is greater than another card if they have a higher rank. For example, or however, if the rank are the same, card with the higher suit is greater than the other card. The same logic applies to the less than operator. The equal to operator should check all that stuff. So less than, equal to, greater than. Okay, so tips. The dot index method should be a useful way. Which suit is greater than the other suit? Which out of diamonds? Hearts and clubs. Spades, I imagine just in this order. So clubs is number one, or clubs is the worst. Spades is the best. Ace of spades, right? Hearts is next best. Diamonds is third best. And cool. So equal then. So it seems that we need to make a rank for these suits. So equal then is, well, there shouldn't ever be two equal cards then if we have them ranked by suits, right? So a card is the rank and suit put together. Equal then. So if self.rank is less than other.rank, right? Return, or equal to, sorry, I forgot we're in the equal to bit. This one's less than, so we'll put that here. So less than and greater than. Boom. So we got the ranks handled. Now, what about the suit bit? I'm a little bit dicey on how to, oh, you know what? This isn't going to be, we do need to index them. I see, because they're all just strings. They're not numbers, and we can't just make them integers. So the value I want to give to this is 11, 12, 13, 14. So we'll say 2, 3, 4, 5. Okay, so it becomes a little bit more dicey, right? So let's say, so self.rank. Is there a way we can do the constructor where if the rank is the jack or queen, we could just append index of it, right? Yeah. Okay, let's do this. Let's do this. So I'm going to say equal other. I just want to see 2 of hearts. So that's where we're passed in. Great. So we kind of need to map which ones are in which value with the rank index is what it says in the suit index. Now, I'm not sure how to do this in a proper value way. So let's see. So self.rank index. Let's just try. Can you do if statements in a constructor? So if self.rank, or if rank is equal to jack, self.rank index equals 11, right? So we can maybe just enumerate these. Is that what Python's thing? How to make strings integers in Python? How to make strings integers? Oh, not in Java. Gross. Use the int. Got it. Easy peasy. Okay, so that's going to be how we're going to do this, I believe. And I'll just copy this down. Jack, queen, and king, and ace, of course. I believe that's numero uno. So we'll just give them a monetary numerical rank. That'll be the easiest, I believe. And then else, I'll just say self.rank index is equal to the integer rank. So let's actually leave the suit and rank what they are. We'll do that. So that'll handle the ranking index. So this will, for 2, it'll make it an integer 2, so on and so forth. So, and then let's do the same for the clubs and spades, I suppose, for the suit index. So we can kind of, I guess, compare those in a programmatic way. Let's see. Boom. So if suit is clubs, we'll give it a value of 1. How about that, right? And if it's diamonds, we'll give it a value of 2. And if it's hearts, we'll give it a value of 3. And then, of course, for spades, we'll give it a value of 4. Spade. Okay, so that, I think, should instantiate this. And then we actually don't need to do, this needs to be a suit index. Rank index, we don't want to overwrite that, right? Okay, so boom, we have a rough value instantiated with this, so our suits and ranks. And then here we could just say if self.rank index equal to other rank index. So other, I imagine we're building the cards. Boom. Okay, so I think that'll handle a lot of it. Now, where does the suit index come into order? Okay, so greater than, if another card has a higher rank, however, the ranks are the same, the card with the higher suit is greater than a card. So that only applies to the equal thing, right? Because if the rank index is less than, if I have a 6 of spades, it's still less than a 7 of clubs. A 6 is less than a 7 no matter the suits, right? So this is just a secondary thing for this case, right? Because if it's less than, it's always going to be less than. You always look at the rank index number 1, and then only in the cases of equal, but I'm trying to think about how to do this. So if rank index, so does this need to be an or statement? If and I guess I'm not sure where we'd want to compare, but it would be and self suit index, right? So we've defined them here. It's to be greater than the other, I suppose, right? Oh, you know what? Maybe we just do it here. So and say or, right? So if these things are equal, or suit index, boom. So maybe that's the case. So or this. So if they are the same card, then we do look for that. Okay, that makes a little bit more sense. Okay, let's try. Shooting from the hip, folks. Let's make sure we got these right. So greater than. Let's try. Dang it. Integer rank. All right, ChatGPT, real quick. Let's get it done. Let's get it done, folks. Let's get it done. We're getting a little close on the time, but that makes a bit more sense because I'm a little bit tired. So let's take a piece even at the solution real quick. So rank index equals ranks index suit. Interesting. Oh, and that one needs to be, well, that's the way to do it. That's a whole lot less work. But this other stuff is about right? Maybe. No. Okay. All right. We're going to get this thing down real quick because I'm so freaking exhausted. I'll tell you what. War, here we go. Okay, so guys, I need to sleep after this. Holy crap. I might do a coffee nap where you just chug a bunch of coffee, take a 20-minute nap, you wake up, the coffee's hit. You're back and dialed. Okay, yeah, guys, not gonna lie, gonna go do that. I'm definitely gonna go do that. Oh, so let me just let's see. So we got the war. Yeah, let's see real quick. Let me read this and at least try to understand some of the codes. So the card game, we're getting the deck of cards. Oh, from the last deck that we built, so that we could shuffle the cards. Super and knit. Self player hand 1, self player hand 2. We could deal the hands. We could battle and then deal the hands. Okay. You know what? Let's not half it here. Oh, I can't undo. Okay. Let's half it here. Guys. Bear with me. I'm living on a coffee and a dream today. But that's polymorphism as a whole, which is fun. We've about wrapped it up. We've about got the deal done, which is fantastic. Not gonna lie, I feel a little bit terrible on kind of getting by on that last one. But guys, I can't be 100% perfect all the time. I gotta go nap. Like I'm dying right now. Yeah. But I'm gonna cut this video. I'm gonna get it edited and out for you guys. I hope it was at least entertaining, at the very least. And we're gonna build a book block next. It should be a good time. It'll be a great time. I'm looking forward to it. We're right on track. We're cranking out these programs. These modules, and we're learning as time comes on. So it's really enjoyable. Just learning the Python and the Python language as a whole. It's very readable and very fun. So I've thoroughly enjoyed it. And about 5 more modules, and then we're into the JavaScript territory again. And then we're super excited for Go. To be honest, it's actually gonna be super fun, I think. Yeah, and then I'll feel pretty confident, or at least a little bit more on the back end with running through this, because even the CLI stuff was huge for me. Just figuring out some grep commands and that's stuff that you just button up the cracks in your understanding, and it pays dividends for a very long time. So I'm very excited for it. And then obviously these things are all super fun. Kubernetes and some crypto stuff. Dijkstra's algorithm, that's a goodie. So yeah, super excited for boot.dev. They're the greatest things ever. But I will see you guys on the next one. Cheers.